Hi everyone, I am sampling from Group 5. My group members and I are going to talk about man-made satellite. From this topic, we will learn about orbit of satellite, geostationary and non-geostationary satellite, escape velocity, benefits and implications of escape velocity, and the last one, solving problems involving escape velocity. And I am going to talk about orbit of satellite. Here are two examples of man-made satellite from our textbook. There are International Space Station ISS and MESA satellite. MESA is actually Malaysia East Asia satellite. They have a much different. ISS can be seen because it has a large size and it is not far from the Earth. It's only 408 kilometers, but MESA we cannot see it because it's small and it's very far from Earth, which is 35,786 kilometers. Satellites move in orbits at specific height and suitable linear speed. Linear speed is actually the speed that the satellite orbits the Earth. How to establish and determine the linear speed of satellites? It means that how can we calculate the linear speed of satellites? Actually, we just use two formulas and we combine it, and then we will find the linear speed. Later, I will show you. Now we look at the detail of the formula first. The first one is centripetal force. The formula is F equal to mv squared divided by r. The small letter m is mass of satellite, the v is the speed of satellite, and the r is the radius orbit of satellite. The radial orbit of satellites is this line, which is from the center of the Earth to the orbit. This circle is the orbit. And the second is Newton's universal law of gravitation, which is also known as gravitational force. It is force equal to Gmm divided by r squared. G is gravitational, m is mass of the Earth, the small letter m is mass of satellite, the r is the radius orbit of satellite. As I said in the previous slide, I will show you how to calculate the linear speed of satellite, right? I will show you the formula. Okay, we need to calculate the speed. So this is just like our mathematics. We solve the equation. We need to solve this equation. This means centripetal force equal to gravitational force. So I write it as their formula mv squared divided by r equal to gmm divided by r squared. We need to find linear speed, right? So we need to find out this v. So we solve this equation law. First we move this r to the back, becomes times r. Then we delete this and the square, this square. We left one r. Then we move this m to the back, becomes times 1 over m. And we cancel this m and this m. We left v squared equal to gm divided by r. And finally, we move the square to the back, become the square roots. So we calculate the linear speed of satellite by using v equal to square root gm gravitational times mass of the Earth divided by radius. So linear speed is actually depends on the radius of its orbit. If the satellite orbits further from the Earth, the speed is slower. But if the satellite orbits near the Earth, the speed will be faster. Actually, there is also another formula that we can calculate the linear speed of satellite besides this formula I showed you in the previous slide. I'm sure you saw their difference lah. Okay, this is divided by small letter r. Small letter r is the radius from the Earth center that really go through the satellite, go through the orbit of satellite. But this another formula is divided by capital letter R plus h. Capital letter R is actually the radius from the Earth center to the Earth surface, and the h is the height of satellite from. It means the distance from the Earth surface to the satellite. So, the radius of orbit is equal to radius of the Earth plus height of satellite. You look at this. Is this equal to this plus this? Same, right? Yes. If the linear speed of the satellite becomes less than the required linear speed, the satellite will fall to a lower orbit and continue to revolve towards the Earth until it enters the atmosphere. If the linear speed is lower than the required linear speed, the satellite will fall to a lower orbit. The movement of the satellite at a higher linear speed against air resistance will generate heat and eventually causes the satellite to burn. Oh, finally the last slide from me. Okay, I will show you an example question to calculate the linear speed. To find out the linear speed, first we must know what is the formula to find out the linear speed of satellite. I have told you there are two formulas that we can calculate the linear speed of satellite, right? Okay, what are the formula? The first one is V equal to square root gm divided by small letter r, and the another one is V equal to square root gm divided by capital letter R plus h. You can use either one formula to calculate the linear speed of satellite. The answer will be the same. I'm going to use the formula to calculate for this question. You can use this formula yourself on your own. Okay, first we must find out the G and the small letter r, right? G is the universal gravitation constant. An important information: universal gravitation constant is this. Please take notes. And the m the mass of the Earth. The mass of the Earth is 5.97 times 10 power of 24. The last, small letter r, the radius of orbit. From this figure, it already gives us an information that h is equal to 20,200 kilometers. H is the height from the Earth's surface to the satellite. Now we need to find out the radius of the Earth. The radius of the Earth is 6.37 times 6 power of times 10 powers of 6. So the radius of orbit is 6.37 times 10 power of 6 plus 2.02 times 10 power of 7. We get the radius of orbit 2.657 times 10 power of 7 meter. Then we put it in the formula. Then we will find out the final answer. Thank you. And next, Gwen will talk to you about geostationary and non-geostationary satellites.
Hi everyone, I'm Gwen Torshan. Now we will see the geostationary satellite and non-geostationary satellites. We will see the geostationary satellite first. It is in a special orbit named the geostationary Earth orbit and move around the Earth in the same direction as the direction of the Earth's rotation on its axis. Its orbital period is T is 24 hours. That is the same as the period of the rotation of the Earth. It's always above the same geographical location. Next, we will see the non-geostationary satellite. It's normal in a lower or higher orbit than the geostationary Earth orbit. Its orbital period is shorter or longer than the 24 hours. It's above different geographical locations at the different time. This is the example of the non-geostationary satellite, GPS. Now we will see the comparison between geostationary and non-geostationary satellite. Geostationary satellite, its direction of motion is same as the direction of the Earth rotation. But the non-geostationary satellite, its direction of motion did not be same as the direction of the Earth rotation. Geostationary satellite, its orbital period is 24 hours. Non-geostationary satellite, its orbital period is shorter or longer than the 24 hours. Geostationary satellite, it is above the same geographical location, and the non-geostationary satellite, it is above different geographical location. Geostationary satellite, it is used in the communication satellite. The example of satellite is MEASAT. And the non-geostationary satellite is used in the Earth imaging, GPS, weather forecast. And the example of satellite have the Tiong SAT, Raja SAT, PP, and ISS. And the similar of them has they both orbit the Earth, and the formula of V and T is the same. There was the example of the geostationary and non-geostationary satellite. This is MEASAT, and the Tiong SAT, ISS, and the Raja SAT.
Now I would like to talk about escape velocity. Escape velocity is the minimum velocity needed by an object on the surface of the Earth to overcome the gravitational force and escape to outer space. The SI unit of escape velocity is km per second, while the formula of escape velocity is V is equal to square root 2 gm per over r. V is represent escape velocity, G is gravitational constant, M is mass of moon or any planet, where r is radius of moon or any planet. Next, let us look at the example of escape velocity. This picture shows an object launched at escape velocity. This object can overcome gravitational force and move at infinite distance from the Earth. That's why the formula of escape velocity is V is equal to square root 2 gm per hour. Because escape velocity is achieved when the minimum kinetic energy of an object is able to overcome its gravitational potential energy. As such, minimum kinetic energy plus gravitational potential energy is equal to 0. That is 1 over 2 mv squared plus negative gmm per hour is equal to 0. V squared is equal to 2 gm per hour. So V is equal to square root 2 gm over r.
Hi everyone, I'm Dr. Masihui. Now I'd like to present the benefit and implication of escape velocity. High escape velocity of the Earth, that is 11,200 ms per 1. One of the benefits is the Earth is able to maintain a layer of atmosphere around it. Molecules in the atmosphere move at average linear speed of 500 ms per 1. Atmosphere velocity is lower than escape velocity, and molecules that are moving randomly will not able to escape from the Earth into outer space. Next, high escape velocity of Earth also enable commercial aircraft or fighter jet to fly to high level in the atmosphere without the possibility of escaping into outer space. Linear speed of commercial aircraft is 250 ms per 1. Linear speed of jet is 2,200 ms per 1. Both their linear speed are lower than escape velocity from the Earth. Next, the launching of rocket requires a lot of fuel to produce high thrust that enables the rocket to achieve escape velocity of the Earth. It can send the spacecraft into outer space. That's all from my presentation. Now I'll pass the floor to Croatia to present about solving problems involving escape velocity. Thank you.
Let us solving problem involving escape velocity. Ignoring air resistance, what is the minimum initial speed a projectile must have at Earth's surface if the projectile is to escape Earth's gravitational pull? So we can use this formula to solve problem. V is equal to square root 2 gm over r. So square root 2 multiply 6.67 times 10 power negative 11 multiply 5.97 times 10 power 24 over 6.37 times 10 power 6. So it's equal to 1.12 times 10 power 4 meter per second. The answer is equal to 11.2 times 10 power 3 meter per second. We can convert the answer into kilometer per second by using this formula. So the answer will be 11.2 kilometer per second.
The end. Thank you.